Hello everyone. So today we are going to see one of the very important theorem and the very basic theorem in vector spaces that involves kernel. Okay. So if you have a linear transformation, so V and W are my vector spaces, T is a linear map, then this linear map is a one-to-one function if and only if its kernel is 0. That means if a kernel only has a 0 vector, then we say that such a transformation is a one-to-one transformation. And other way as well, if a transformation is one-to-one, then the kernel is singleton 0. Kernel does not contain any other vector other than the 0 vector. Okay, so let's start with the proof. So suppose your T is one-to-one. It's a one-to-one linear function, linear transformation. And what you want to prove, your claim is that kernel of T is nothing but 0 vector. Now before that you need to recall, if you have a function from set A to set B, when you call that function as a one-one function, so if, what do? If your f of a1 equal to f of a2, you assume this, then you prove that a1 equal to a2. Okay, so if you have two elements whose images are same, then the elements has to be same. That's what you mean by one-to-one. That means distinct elements have distinct images. Then we say it's a one-to-one function. Okay, now I want to prove that the kernel has only 0 vector. Okay, so suppose you have a vector in a kernel. We will prove that this x bar has to be 0 bar. It does not have any other choice. Okay, now as x bar is in kernel, so t of x bar is 0. But we know that under linear transformation, t of 0 is always 0. T of 0 bar is 0 bar, right? Okay, now we use a definition of 1-1. If f of a1 equal to f of a2, then a1 equal to a2. So since t of x bar equal to t of 0 bar, therefore your x bar equal to 0 bar. We are done, right? So we took a vector in the kernel and we showed under 1-1ness that vector has to be a 0 vector. It does not have any other choice. And therefore your kernel of t is singleton 0. Right? Now let's go for the other way. Okay, let's prove the other part. So suppose kernel has only 0 vector, then we prove that such a function is a one-to-one function. Okay, so we need to suppose that your kernel of T is singleton 0 and we want to claim that T is 1-1. Okay, so you assume, suppose your f of say v1 equal to f of v2. What we want to prove? v1 is equal to v2. That means it will be proved that t is 1-1. Okay, but what is this? Okay, I am using t as a notation, so let me write t over here. You bring this on the left hand side. What do we have? T of v1 minus t of v2 equal to 0. 0 means it's a 0 in W set. Okay, but now t is a linear map, so t of v1 bar minus v2 bar is equal to 0 bar. But what I'm having, I'm getting an element whose image under t is 0. So this implies what? Your v1 bar minus v2 bar belongs to kernel of t. But kernel of t may you only have a singleton vector. But what is kernel of t? It is singleton 0. So therefore this has to be 0. v1 bar minus v2 bar is 0 bar, and this is singleton 0. So what is this? You take v2 on the right hand side, we have v1 bar equal to v2 bar. So therefore if a kernel has only singleton 0, then using linear transformation one can prove that that function is a one-to-one function. And that's why it's very important to study kernel. Okay, many times it's difficult to conclude whether the function is 1-1 or not. So what do is we try to find the kernel, and if the kernel has only 0, our job is done. So let me take some examples so that this theorem will be clear to you. So suppose this is a function, t is a linear map from R2 to R2. Question is this function a 1-1 function, or is this transformation a 1-1 transformation? Well, I don't want to go by definition, so I will try to find the kernel of t. Okay, so what is kernel of t? All x comma y in my domain such that its image xy is 0. What is 0 bar over here? 0 bar in R2 is nothing but 0 0. Okay, so it is nothing but this as it is. What is t of xy? It is x minus y, x plus y equal to 0 0. And now you equate this, what you get? You get x minus y equal to 0, you get x plus y equal to 0. If you add these two equation, after adding them, this goes away. You have 2x equal to 0 and therefore your x is 0. Once your x is 0, you put in either of the equation, you will get y also 0. So if you have an element in the kernel, then what is your x and y? They are nothing but 0 0. That means kernel has only one element which is a 0 vector, and therefore this transformation is a 1-to-1 transformation. Okay, so say you get answer in 3 lines or 4 or 5 lines, but if you go by definition it will take longer period. So therefore finding kernel always reduces your job. Okay, now suppose, let me take one last example. So if you have a t, say from R3 to R2. Okay, suppose if you have x, y, z goes to say x minus y, y minus z. Okay, so what is the kernel of t? Kernel of t is nothing but set of all points in my domain. My domain is R3 such that t of x, y, z is 0. What is 0 over here? 0 is 0, 0. Now what is this? This is nothing but, let's write this as it is. What is t of x, y, z? X minus y, y minus z equal to 0 0. And now when you equate, what do you get? You get x minus y equal to 0, y minus z equal to 0, and both of them imply x equal to y equal to z. So whenever you take all the 3 components same, that answer will always be 0. For example, if I take 1 1 1, what is the image of 1 1 1? 1 minus 1, 1 minus 1. Answer is 0. If you take 3 3 3, what is the image? 3 minus 3, 3 minus 3. If you take pi pi pi, so it will be pi minus pi, pi minus pi. So we are having non-zero vectors in the kernel. What does that imply? That this function is not a 1-to-1 transformation. Okay, so I hope the concept is clear. Let me give you some homework problems. So these are the 2 problems. You have to tell me whether this is 1 1 or not. So you find the kernel and tell me. So you will write down for first what is the kernel and conclude whether 1 1 or not. Similarly for second, write down what is the kernel and then conclude whether it is 1 1 or not. So if you have a doubt in this, you can ask me in the comment section, or if you have any other linear transformation whose kernel you want to find, or you want to check whether it is 1 1 or not, and you are not able to do that, you can ask me in the comment section. And if this lecture is clear, do not forget to like, share and subscribe. Thank you.